Hey everybody, welcome back to another 3D Hangout. I'm Noe Ruiz, designer here at Adafruit.
Hey guys, I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come here to bring you 3D printing tutorials, techniques, slicing techniques. And what do we have on the show this week?
That's right, this is the show where we come together every week. We combine DIY electronics with 3D printing. We got some segments for you guys. We always start off the show with, what are you prototyping?
That's right, so we take a look at some of the behind the scenes, upcoming work in progress projects for future episodes.
That's right, then we'll jump out and jump into some 3D news.
That's right, every week there's a segment around the world of 3D printing, and we scour the net to find all the interesting stories for you guys.
Yeah, like a little STL show and tell. And then we'll jump into our weekly video.
That's right, cosplay this week. We're showing you how to make a Gunblade.
Oh my goodness. And then we'll show you how to slice the Gunblade, maybe modify it, make it work with your printer. That's going to be on the layer segment. Really fun segment there. So with that, why don't we jump into what are you prototyping? Huh?
Actually, let's jump into a coupon code. That's right. Every week we have a discount for you guys. This week it's Blade. Get 10% off on your 3D print accessories, printers, and of course electronic goodies.
That's right. Yeah.
Expires at 11:59 p.m. tonight.
Yeah. You got it. So, you know what? We're prototyping stuff. We're going to jump into that segment. So, over the weekend, we encountered some problems with our PrinterBot, PrinterBot Plus.
Yeah, so this was entirely our fault.
So what happened here?
We left some of the metal printing filament inside there, just idle. We left some copper fill in there, and I totally forgot about it and just left it on with the temperature turned on.
For a whole day.
For a whole day, so came back later and realized that. And
it wouldn't print.
Yeah, so it looks like the PLA burnt off and left behind all of the copper material. So just took a lighter here, heated up the nozzle after taking it off, and then tried to burn as much residue as we could off of there. And we dunked it into some acetone, sort of loosen that up. And we went in there with a Q-tip to try to get any of the remaining junk out of there.
Yeah, you also used a very fine, not a safety pen, but I guess a needle, like a threading needle. And then it's just the process of going back and forth, dipping it in, heating it up, dipping it in again. You want to be careful, of course, when you're doing this with acetone. Acetone is a very nasty chemical. You saw it there boiling. You definitely probably don't want to do that. And this is kind of the way to unclog your nozzle. Now, we went ahead and we ordered some more nozzles from PrinterBot. Those haven't come in yet, but it's cool that you can sort of fix your clog if you know what you're doing, or at least if you're willing to. So here it is, what the nozzle looks like, or what the extruder looks like without the nozzle in place. So if you ever notice why a nozzle is shaped like a bolt, that's because it's meant to be screwed on and off. So we did that with some pliers. And here we're using a longer needle to poke down any remaining filament. There was a lot of fumes that came out of it, but here it is extruding again. It extruded out. You know, this whole process took maybe about 20 minutes because it was really, really clogged up. But now the PrinterBot is working. It's printing, and you know, that's how to pretty much fix and unclog a nozzle, is to use some acetone, some elbow grease, right, and a little bit of fire.
The takeaway from this is don't leave filament idle with the temperature on without printing.
Or at least, you know, metal
hours.
Yeah, at least metal filament.
Yeah, the metal filament, yeah, definitely don't do that.
That was the PrinterBot Metal. It's in working condition right now. It's still a really good printer, and we got another printer. Oh my goodness, what is this?
This is the world famous Ember.
Elusive, yeah.
Elusive Ember. It's a DLP SLA 3D printer.
It's from Autodesk, and it was a part of the sort of
the Spark platform, the open platform that they're trying to promote. And it's marrying, you know, Mesh Mixer and all of the other 123D apps together to work with all of the hardware here. Now,
I say it's elusive because there really aren't many people coming out with videos of the thing working, or even photos of it really being there. But it is a real machine. It actually does work, and it's not just a renderer. So we got our first, we unboxed it literally yesterday, and we put together a quick little first look video and even some little things that we wanted to share with you. So
right off the bat, we encountered some problems.
It wouldn't print.
Yeah, so there's something wrong with the hollow sensor in where the height for it wasn't correct when it left the shop.
Yeah, so what is the hollow sensor?
So the hollow sensor is used to detect where the tray is when it's spinning around. And the way to edit that is to remove the front panels. So you're going to use a number 10 Torx screw on the side, and number 2 Allen key, wrench to get that off. So just remove those from the bottom and the sides there.
So it's pretty easy to take off the front cover, and this is really where all the electronics are living, in the bottom of the printer, a lot like a Delta machine. So
yeah, so here you can see the motors and things. And interesting thing when I was reading through some of the documentation, when you load in through USB on the computer, it mentions BeagleBone Black. So we'll post up some pictures a little later, but it looks like there's a custom BeagleBone Black in there.
Very cool.
Circular shape, it looks like.
Yeah. So what we're doing here is we had to measure out how far the little nub, the hollow sensor, is from the surface. So we used our calipers to make sure that it was around 2 millimeters. It was approximately 2 millimeters. So here's a sort of close-up shot of the sensor itself, and it's actually really easy to move. It's a plastic nut and washer there, and you just unscrew it and then screw it back in. And once you have it in the right height, you just screw it back in together. And this machine is really a lot like a fully working appliance. It looks a lot like a Keurig coffee machine or something. So it's really nice and sleek looking, and the design of it is incredibly nice. So that's it there. Now you want to talk about the printing? How's the printing
so
like?
This is how the printing works. It's sort of like shooting a whole image at it at once, as opposed to like a Form Lab where it's sort of drawing out the shape with the laser. And you can see here in some of the shots, if you just slow it down, it's actually a whole slice of an image that it's projecting onto the resin, and then it's curing with a UV light underneath there.
Yeah. Yeah.
So it's using the peel technique, which sort of, if you can rewind that time lapse back, you can see that it actually shines the light and then moves over to sort of peel away.
Moves,
yeah, so that's the constant motion that you see for the printing.
Okay.
So we have a full video of some of the parts that we're printing, and some of the first step-by-step of cleaning your part. There's a lot more that goes into these than a regular FFF or FDM printer. A lot of protective gear you got to wear when even handling any of these things, so it's definitely a lot more than we're used to.
Right. So we do have the print, and we're just going to take a look at it right now and maybe compare it to an FDM print.
Yeah, so you can definitely tell the difference on 25 microns when compared to an FFF.
Yeah, you can see a lot of the ridges there. You can see all the overhanging issues. And tell me a little bit about the support material, right, for this thing.
Yeah, so if you see in the time lapse before that there's a lot of support material generated inside of Mesh Mixer. They use the tree branch approach, which is used to hold all of these little guys together. We're going to try a different orientation to see if the print comes out a little bit better, because as you can see here, it didn't completely come out perfect.
Yeah, it broke off a little bit, yeah.
Yeah.
But you did scale the model because it wouldn't fit on the bed, so you actually scaled it down just a bit. And when you do that, your walls just get so much thinner. So maybe that is
Might have been, but then all of this would have broke off too.
Pretty well. Yeah.
But pretty cool for printing really small objects. We have some cool projects planned, like a custom keyboard caps, Adafruit chest set.
Ooh, that's a fun one. And a couple other things that will come out. Now that we actually have the printer, we can start brainstorming on some projects that require a lot of detail. A lot of small stuff too. So this is clear resin. It actually looks a lot like glass or something, or acrylic. It's very clear.
UV reactive, some sort of polymer, liquid polymer that is quite dangerous and stinky. We actually cannot have it back here. We have to throw that guy into the garage because just how smelly it is.
That's the main thing that's a little bit different, is we really can't operate it here in the studio. We actually have to operate it in the garage. It's a little bit smelly. A lot of hands-on. You got to be very, very cautious when handling the resin and cleaning it too. So
a lot of gloves and eye protection gear has to be worn when you're playing with this. Turn off autofocus.
We just need a lab coat, and then we'll be good to go. So there's autofocus.
And of course, we'll come up. We'll be bringing you full episodes on some of the way to control it. I mean, it's all operated through I think Ember. Autodesk.com, so it's all through a website.
Yeah, the slicing there, all through Autodesk.
There isn't an immediate way to do any of the controls on the printer, like moving the head up or anything like that. Not what we're used to, but we are coming out with some fantastic prints.
Yeah. So that's the Ember machine. We'll be taking a look more about it, obviously in the coming weeks. But what I've been working on, I've actually been working on this. This is pretty fun. This is a cool idea from Becky Stern. She's got that drone hat, right? And it's got the drone embroiderment here. But she had the idea, you know, why don't you guys make it in NinjaFlex? Print out your own in NinjaFlex. So that's what I did. So this says 3D print. This is printed in NinjaFlex, and I put together a cool layer by layer tutorial that talks about using the text tool to make all sorts of cool, you know, text labels. And the way it's put into the hat is I have these little pull tabs on the sides here, and those are safety pinned into the hat. So you can see here in the hat, it's got that little tab, and then you just you know, poke it through. And it's a really fun and easy one. You can make all sorts of different names. Here's a nice open source one. So it's Floss. That one's for Becky. And then you can even do sort of custom names too. So this is my name here. And of course, this is printed in NinjaFlex, semi-flex actually, because it's got really nice retraction here, and it prints a lot better on most printers. So definitely check that out. We got a coupon code for you if you want to.
If you want to try out some of this new NinjaFlex colors that we have in the shop here.
Oh yeah, we got new colors.
A brown that we're going to use as a wood, and you can also use it like for pigment. It doesn't really match my skin, but you use it for like prosthetics, and of course the enable, you know, hands and things like that to sort of match skin color.
Yeah.
So it's gonna be fun. You can get a copy of your own. You get 10% discount. Use the code BLADE during checkout. Expires tonight, 11/59. Doesn't work on gift certificates or software.
That's right, only atoms. Okay. Very cool. All right, man. That's our prototype segment. Very fun stuff. Got a lot of cool things going on. 3D print hat. Woo!
Let's go ahead and jump into the news in the world of 3D printing.
Okay. We'll take a look at some clips first. This is a really fun one. DIY electronics, full force. 3D printed RC snowblower. Pedro, tell me about this. This thing looks really cool.
Yeah, so this was modeled by Skyper.
Sorry for butchering your name there.
Yeah, so this is a 3D printed blower for the Blizzard.
For the Blizzard.
This is all 3D printed. It's a kit that he's selling. As you can see there, if you continue,
oh yeah, sure.
Hit play, should be.
Oh, cool. So here it is in the snow, actually. Bulldozing some snow here, so really cool. How did you put this together? Or how many? Yeah,
so this could be added to any vehicle that is self-contained. It's printed on a modified XYZ DaVinci printer. It's fully designed inside of 3D Studio Max, and he did a lot of testing with this. He really put it up in the elements with all the Blizzard going on, and this would be awesome to have, sort of a Roomba-esque little snow blower to clean up your driveway there. I mean, of course, it won't be able to clean up, the massive amount of snow that's going on right now.
It's a very cool concept, though, that it's so miniaturized and it works very well. Plus, it's really fun. It looks like he's, it's on a remote control transmitter, so you're controlling it that way. You can't do that with a Roomba. Yeah. You can with this. It's very cool. So yeah, we got a blog link for you guys in the description below, so you can check out that. And is it free to download?
No, this is a kit that he's selling.
Okay, kit that he's
looks
selling.
like this. Took quite a while to design, so definitely understand. Concern in just giving it away, but it's only like $60, and a lot of the parts. It comes with all the parts. Yeah, no, that's just the STL.
Okay.
There's other prices on this website you can check out. But yeah, this is definitely a cool way to get into a little miniature robotics that are actually quite functional. If you scrub through that, you can see all the work that it's doing. Yeah, this would be pretty cool just for
wow, it's really going through everything. Oh my god! So you can clear out your whole driveway, huh? In just a couple of hours, as long as it takes to print it. Okay. Well, next up, we got a pretty cool tip for you guys. This is from the new hobbyist, or Chris, as we like to call him. He put together a dual extrusion of the Left Shark. Left Shark.
Yeah, the very famous, in illegal battle.
Famous, yeah. So this is Left Shark. It looks like he's got it in Mesh Mixer, and he goes through the process of making a dual extrusion model. So we've looked at dual extrusion before, and you'll know that it's kind of a little tricky to set up your model that way. So what's he doing here?
So here's painting the meshes on what is going to be for the second extruder. He's selecting there the belly, the underarms, the eyes, so that'll be printed in white. the rest in blue.
So you just sort of paint on it, huh?
Yeah, so this is some of the techniques for doing the selection with the brush and then doing your boundary, smoothing out your boundaries for all this. This is a really cool technique for anybody who wants to learn more Mesh Mixer.
Yeah, so you don't necessarily have to model the base. This is a cool way to take an existing model and then turn it into a dual extrusion optimized model. So that's really cool. Awesome. Shout outs to you, Chris. This is a really cool tutorial. I think a lot of people are going to benefit from it. And NextMesh is a pretty good tool for doing this. It's one of the best for messing with meshes.
Yeah, so you can control printers through here. I think you control the Type A machines, Series 1 machine, which we'll be covering a little bit later, and a bunch of new other printers too. So yeah, if you just scrub through there, it shows you the techniques of sort of extruding that out, subtracting that from the model.
Okay, so it's a little bit of song and dance that you have to do, but definitely worth it if you're into dual extrusion. Wow.
There's the model, what it looks like when it's
freaky,
done.
like a big old mouth or something. So very cool.
Okay, check that out. Yeah. Okay, next up we got some cool little wearable 3D printing, little modifications that you can make to maybe your hoodie or sweater or something. Yeah, so it looks like a zipper that can hold your
headphones,
your headphone cords wiring to keep them from getting all tangled up.
It's
so this is a cool little add-on, yeah.
Very cool. And this is available to download?
Yeah, you can get this on Thingiverse. This was designed by 3PVDB. And zipper earphones makes finding that one last earbud a bit easier, and it keeps it from tangling. So definitely check out the model. Maybe you can work this into a 3D printable design.
Yeah, if this was Ninja Flex or something, it'd be a lot more flexible, huh?
Yeah, definitely experiment with this.
Very cool. All right, next up, we got another RC car. This is an RC Mars rover. So all 3D printed, and if you look at the design, it really looks like it's just a bunch of brackets that's put together to make this, to make the electronics move, which is really cool because it's a really sort of standard design. Like if you think about your car seat, you're just a bracket in the car. So this is really.
We were looking at some models of like some really fancy, RC stuff. I think it was the leaf blower, and we were looking at it. It's like this is just brackets.
Yeah. But this is really cool. It seems it has like all motion, all 6 wheels are running there. And any details on it?
Yeah. So this was modeled by we have here Mocar. It's a 3D RC inspired by the Mars rover Curiosity. The parts are all 3D printed. Main processing unit is an Arduino Mega. Okay. It's moving with 6G servos, metal gear, and it's edited for 360-degree rotation, and it's steering using 6 standard 9G servos.
Very cool.
And I really love the way that it can go into circles. I think if you scrub through this,
sure, it's almost out.
Must have been another
it's
in a different video. Yeah. Oh yeah, it's one cool thing. There's more videos on the blog if you check out where it's sort of going around in circles like that and showing the lights off.
Okay.
And doing a lot more movement there.
Very cool.
Very cool project. You can 3D print yourself. It's on Thingiverse. Get the link on the blog.
Cool. All right. Next up, we have another update from Mr. James Bruton from X-Robots. If you aren't following James, be sure to follow him. He's got his YouTube channel on X-Robots. Every week, he's bringing you updates to 5 or 4 of his really, really big projects. So this week, it's the Hulkbuster. He's been working on all the sort of stuff on the outside of it, trying to get the final shape of it.
Yeah, lately it's been all the retraction. Little hinges and how like everything moves apart so you can jump into the suit. You scrub a little bit.
So he's jumped into the suit. He's in the suit and he's working out the movability of it, the practical use of it. Can you move it around? How more optimized can you get it? There's still a lot of missing pieces of it, obviously, but it is coming together really, really awesome. This is really cool. So in this episode, he literally walks us through some of the things, and he's showing us this is where it's come from. And in just a couple of months, it was just a wooden structure, and now he's doing it up
a little
really
bit there.
big,
you can see what the main build is. It's on the legs, so he does a lot of the construction and beta testing with Legos, so just to see the angular motion of how everything goes.
Right, and then he
models
walks
everything
us through
3D.
Yeah, he walks us through
near
the CAD.
end there, you can see what the final hinges look like. So this will let him climb into the suit.
It's for the legs. Yeah.
You scrub a little bit more, you can see what it looks like. He's using Ninja Flex dual printed parts, rigid and flexible, so it can sort of turn and still have that rigidity for adjusting the hinges here for the legs.
Yeah.
So really cool. Check out the video. Very informative there.
Yeah, very cool. Again, he's on YouTube. Check him out at X Robots is his YouTube channel. And every week, every Tuesdays and Fridays, he's got a cool project update for you guys. So check that out.
Next up, we got
a cool sort of how it's made. So the Make team went out to Maker Geeks, their facility, and they took a look at a glimpse of how is Filament made.
Yeah, so a lot of cool techniques here and insights on what happens when you get like an oval shape inside of your filament. What's actually going on. It's like the cooling wasn't correct on any of the zones. It talks about like the granulars that come in, how the pigments that have to be added, mixtures and things like that for creating your own filament. Yeah. He also walks through some of the just how his setup is, putting it together and all the different zones, how it needs to coil and go through water to do all the proper cooling and all that. So very informative.
Very big process. It's a lot more involved than doing the DIY filament like we did a couple months ago. Very, very different. This is how it's done properly. You see a lot of bad filament coming from different sources, and this is one of the folks that take pride in quality of their filament. So we definitely recommend checking them out. And this is a really cool video by Make that they put together. Very, very nice job, guys.
Yeah, a lot of cool takeaways in this one. Definitely check it out.
Yeah. So I think that's pretty much the news, Pedro.
I think we are missing the
sword. We got some other stuff. We got the sword, right? So I got some photos here of this 16th century sword. Oh my God. This is very historical. This is like, how do you take an old 16th century design and then make it in today's technology? Well, you 3D model it.
Yeah, so this is by Nils Anderson. He's a teacher and game developer with an interest in recreating historical artifacts in his spare time. He was looking at some artifacts from the past, and this really leaves us speechless on sort of the modeling that can go into. And I think he used iMaterialize to actually print these in real metal. Yeah. So he is using, I believe, 3 Studio Max for this, for all the modeling in this. Sure. This is really cool.
Polygon modeling.
Yeah, I mean, game developers, so probably definitely 3 Studio Max on this. Yeah. And it's really cool seeing the step-by-step on all of the, figuring out how to recreate all of the texture for that, all the repeating textures for it, and then down to the finished sword.
Yeah. So where can we find more detail on this one?
So this is on the blog as well. You can get more photos for all of the step-by-step there.
Okay. Well, then that's going to do it. I think that's the news this week. Again, you guys can check it out on the Adafruit blog. We also got the links for you in the description below, right? We got those for you there. And now this week, we're ready to show you guys this week's project video, if you haven't seen it already, right? So here it is.
All right. This week, we're looking at how to build a Gunblade, perfect for cosplayers of all shapes and sizes that are into Final Fantasy. So we got an awesome little pendant here. The whole sword is about 850 millimeters long. Wow. So definitely not small. It's a nice weight, so you can definitely swing this around. So all the modeling was done inside of Maya. One of the reasons I didn't use 123D for this one was just because needed to produce this kind of quick. No Maya like back of my hand.
And the there's layers.
You can do layers for this. You can do all of your, you can select vectors. So
sure, yeah.
You can select edges for doing a lot of the remodeling work they have to do. That comes with slicing up a model.
Right on.
I released the SVG file so you can completely edit the handle to to fit your hand if you want a different sort of style.
So that's how this was put together. This was all traced out as a vector graphic first, then you import it into Maya, and then you start piecing out all the things and extruding that way. But I really like that you optimize this for sort of modifying in mind. So you can take this in your CAD package. It doesn't have to be Maya. It could be 3D Studio Max or SolidWorks or something.
Yeah, so everybody has a different size printer bed.
Sure, exactly.
So this is definitely going to help with that.
Okay, and we got some...
Not a small print.
Yeah, we got some tips for you guys on cutting it up later on. Yeah. So let's work right through the workflow here. Like I was saying, you got your SVGs and your AI file, so you can modify you just quickly did a dynamic link and updated it here, and that's really cool. And you use Maya because man, it's got so much power in it. So you got like this this Bevel Plus feature that you can really puff things out and make it look really smooth. and you got so much control over your polygons.
Yeah, so here's some of the printing time lapses of it, and I'm really happy with the quality that's coming out of the Type A machines here.
So this is what made it possible. Without the Type A machine, you really couldn't have printed it this big in very little parts. Now, another thing that made this possible was Simplify 3D.
That's right. So this is all using custom supports that we're going to actually go over how to build for yourself inside of our layer by layer.
Yeah.
So you can just see the precision that's going on in here. It's very just the way that the support structures are laid out with the nozzle, type of nozzle that the Type A is using, and the type of support that's being generated out of Simplify 3D is really the key to really coming out with a clean print.
Oh, yeah.
If you continue here, you can see that the
it breaks off with your hands. It's
very easy.
You like break off all the support, and the gun's still like in place on the bed, which is amazing. You couldn't do this.
And if you could see there that support I'm actually removing there as I'm speaking, it actually looked like it was about to fail, and then it just caught itself and continued going up. Yeah. So it's one of those. Just the way that the support structure that it generates is really good.
And the filament that you're using, this is 175 filament from Ulti Machine. We got it in the shop for you guys, and it's this gray, metallic looking gray, and it's also has semi-transparency to it, and it's got this sort of glitter, so it makes it look really shiny. Yeah. So tell us about this sort of mistake. This is what happens when you print it. You print the very tip of the blade. That's actually a very challenging part, especially with an FDM printer. Tell us, why does this happen? Like, what's going on here?
Yeah, so what's going on is that the heat from the extruder is actually hanging around and actually just, slowly building up. And so you have like this spot of just heat that's, not letting any of the layers cool. It's like melting. It's like,
even with the fan on there, it doesn't seem to do a good job. And you did this several times until you found, you know what? What if I just print 2 of them? So here it is again, printing at 1. You kept trying at different orientations, right?
Yeah. So there's other options that let you print at a different speed depending on how big the object is. But the problem with that is that you're going to significantly slow down your print.
That's not going to
help. You're going to affect the surface quality of the print too. So that's definitely not the way to go.
So this is the way to go. Just print 2 of them far apart from each other so that the head actually has time to travel and cool it down.
Yeah, that actually needs to be an option inside of slicing software where it just goes away for a little bit, comes back. Of course, there'd be retraction issues, which is probably why they haven't implemented that.
But a good part here is that when you're printing them too, you have backups. You can always use one or the other if you need to. So that's really cool. And that's going to work with a lot of different parts. So here's the handle of the gun. Now we printed it in semi-flex, Ninja Flex, because it's got a lot better quality when it comes to retraction. So this worked really, really well here for the handles, and it's in black, so it makes that 2-tone look. Super easy to get off the bed on the Type A machine. It prints really well, of course, with direct drive machines.
Yeah, we don't even need blue tape for this, actually. I think it sticks perfectly to the
oh man, very cool.
To the glass. Yeah, just minor cleanup. It definitely prints a lot more better with less infill.
Sure. Yeah.
You can check out the video on our semi-flex, all the wonderful uses for that in a previous video.
You were using the Haku snips, I think, to just clean those up.
The perfect tool for getting all those little bits and pieces off of there.
Okay. Very cool.
Okay, so after we do our initial cleanup there, we're going to use some E6000 to glue everything together.
Okay, but before that...
Actually, yeah, more Haku flat pliers actually clean up the remaining little support material that sticks around. And as you can see, as I'm taking this off, it doesn't leave any damage to the print at all.
It's very clean.
It's just stuck on there a little bit. But the surface quality that you get out of this is amazing. And of course, some support material inside of the spinning barrel, just a very light amount of support material there. You just stick a small spatula in there and rotate it until it can freely spin.
Yeah, freely spins really nice, and we're going to show you guys in just a second, or a minute, how nice it is. So here's all the pieces. Like I was saying, you got only 4 pieces here. The Type A machine's got a Z of 305, so that thing's massive. And one really cool thing that you found is that you can use these skinny sticks, which are mostly used for crafty projects. You can use it to be the internal structure of your sword. So you put it all together using these little sticks. And the cool thing about that is that they're oriented in a special way so that it doesn't twist off. So it's got a really nice tolerance on it. So you got about, I don't know, 9 different little pieces here. You want to make sure that they're all, of course, the same length. And they just slide right into those little holes.
Yeah, the tolerance on this should be tight enough where you can just dry fit it. But, of course, if you want to swing it around, we'll use some E6000 to glue everything down. And the skinny sticks work perfect instead of a dowel because it's not a round circle or
yeah, it's super small
cylinder. Yeah, so it will definitely fit inside the shape of a blade.
Yeah, this is perfect. Yeah.
So we're going to use some E6000 here. You definitely want to use some gloves.
You don't want to touch this stuff. It's a little harsh, and it's of course a little. It stinks a lot, so you want to do it in a well-ventilated area. And another tip is you want to have like a piece of cardboard underneath your work surface so you don't get any excess glue on there. But yeah, it's as easy as sort of spreading it on there, and it seems to work really well with NinjaFlex. So bridging two different types of material, PLA and TPE, seems to work really well, and you get a cure time of about a day, so you can kind of finesse it and angle it in the right way, because it's a very organic shape, so you're going to want to make sure that it's in the right angle.
Yeah, you want to make sure that none of the edges are coming off there. So
if you have any excess glue, you want to just maybe use a piece of cloth or something to get it off.
Yeah, maybe like a work towel or something, so you don't get any. So you don't get any like little pieces of dust on it.
Sure. Yeah.
And we'll just do the rest to all of the blades here. Just insert a couple drops into the slots and then the flat areas, and all of the sides of the skinny sticks there, and glue all that together.
Yeah, this is a really, really good adhesive because it's not going to turn white on you when it dries out.
Yeah.
It stays, it keeps the color, and it's very clear.
Yeah, so if you have a little bit too much, it's okay. It actually helps seal and hide the seam.
Okay. How about cleanup and finishing, right?
Yeah, you want to use some hobby blade here to sort of clean up and file. Because if you're going to be twirling this thing around, you definitely don't want any support material there cutting your hand or fingers.
It feels super smooth when you did that, so really good. You didn't have to like sand the whole thing down at all. You just had to do just the parts where the support material was. So very, very easy and quick to do that.
So it's going to take about a day to fully cure, and definitely give it time.
So
and then to finish it up, we're going to add a medium-sized split ring, clasp, and a small chain to attach it to the pendant. And then there we go. We got a finished
Gunblade.
Ginormous. Well, not too ginormous.
Yeah, it's the
moderately
right size,
sized.
Yeah,
you can definitely swing that around. Have fun at your next cosplay. You definitely don't want to forget this if you're dressing up as Squall.
That's right.
And yeah, let's go ahead and go to the overhead so we can get a closer look at this.
Yeah, I think you're gonna. You wanted to take the support material off live, right? So
we can still do that after the layer by layer.
Okay, sure.
So this is the Gunblade. Yeah. So this massive guy right here. We want to show off all the detail on this. So yeah, here is the lion logo that's on there.
Yeah, how did you put that together?
Yeah, so this is just a vector file that a lot of references on the internet to sort of play off for that.
Okay.
And I think it's in there like 1.5 millimeters, and the thickness I think was like 2 points inside of Illustrator and whatever that is. Then measure it in real life, but it's on both sides, and all of the geometry is included, just in case you want to move this somewhere else or anything like that, and if it's affecting where you're actually slicing something. So I give this away as a separate separate STL file, so you can do your boolean on that.
Okay, let's take a look at the revolver
part right here.
The barrel, sorry.
So the way you want to print it, I printed it up this way so that the top came out very nice. So you can definitely 3D print yourself some fake ammo to go inside here, sort of complete the look on that. The handle here, semi-flex, you can see how that came out. You can have a cool little indent here for where your hand grabs.
Yeah, it's very comfortable.
And should have added like a final detail here, like a screw just going in there, but you can definitely do that yourself. And then the chain, we just got this at Walmart, I think, for like $2, like a long chain that you can just cut up.
Cool.
Add your clasp on there, attach another split ring to the pendant, and you can just easily take this off when you want to go into battle.
Yeah, now the pendant is, I think, you're just 2 pieces that are sliced in half, and then you just glue them together. So that's how that one's being done, because it does have a little bit of detail to it, 2 layers.
Yeah, it has some raised little beveled parts here.
Yeah. And you could totally print that in copper fill or bronze fill if you wanted that metal weight to it.
Yeah, I definitely want to do it in like maybe some sort of steel or something like that, just to keep the color look.
I would print it in clear resin.
Let's see how that looks like, yeah. So as we go up the blade here, here's the tip. All that comes out with the technique that we showed you earlier.
Yeah, very cool. Now the tip isn't like super sharp, so you,
want
to make it a little bit chopped. Okay, well, very cool.
Is the whole blade, and here's a cool little detail there for the little small barrel that is a part of the design.
Okay.
I like how the way everything holds in together.
Yeah, and I really like the material that we use. This gray. Sort of metallic-looking PLA is really nice. It's a little semi-transparent, you know, if you go really thin. So that's really cool. I've been using it on my enclosure designs too, so that's really cool. So how about we jump into the layer by layer, Pedro? Is that cool?
Yeah, let's go ahead and check out how we actually built the support structure.
Okay, so here we are in Simplify 3D.
So this is the #1 feature I think that is worth the $140 that it's worth.
Okay.
So to start off, we're going to reorient this, and I think you've had some UI suggestions on this.
Absolutely. So in order to manipulate your model, you have to double click on it that's on the side over there, and then you get this little panel, and the panel is really where you want to manipulate. So you got things, you can rotate, you can move it on the X and the Y and the Z, and it's all nicely there and organized, but I think it would be a lot easier if this thing was a flyout menu. So very similar to Cura, where you click on an object, you get this flyout panel that comes out and it's always there. Same thing with Makerware. So this is just one, you know, as many clicks as you can, you know, reduce, the better. So I think that would be a really cool UI change. But anyway, this is where you want to modify it. Once that's all done, you hit OK. Center and arrange is a nice button to have too. And this is really the optimal orientation that you want. So let's take a look at the slice settings, Pedro.
Actually, first here, if you continue, I'm just going to show the differences really in the build volume. So here we're looking at a PrinterBot Plus, and then we're going to switch to a TAS, and you can just see the build plate animate here. So yeah, it's 50 millimeters or 50-something millimeters bigger than the TAS.
So definitely
Type
huge
A,
in terms of the Z, and that's really what you want.
And this is definitely going to save time for printing those ginormous prints.
Yeah. So here we are. Let me rewind back so you can show where is the support material UI.
You can get to it in the menu bar as well, but there's a little icon right on the right side there.
Okay, so there it is.
Pillars. So I like to do my supports at 60%, or the 6 degrees for the angle, and that usually generates a pretty clean one because a lot of printers with the fans and everything can achieve, you know, 45-degree angle prints. So
you clicked on that button that says apply based on overhang angle, and Simplify 3D is going to figure out and just apply what it thinks it can do. Now most CAD packages are going to do this for you, but they're not going to give you the control to delete them and maybe create new ones.
Just
so why don't we show? Yeah. So why don't we show?
So this is where all of the you know, the coolness comes in. All the value for this. So once we go into our cross-section view, which again is another thing that you really need to make this where you can see how it's going to build up. You can see the support material that's going to be inside of objects, and that would cause some problems when printing. So right away in here you can see that the support structures inside of the
they're inside of the little holes for the ammo.
That would totally stop. You know,
you couldn't get that out, huh?
It'd be very difficult to.
How would you get it out? You'd have to like rotate it.
I know.
It's all assembled in one part, so you really have to be cautious. So you just, what did you click on? You clicked on remove existing?
There's an add support and remove support button there. So I'm just clicking on remove and just clicking on the pillars that I don't want.
That's simple. And
it's that easy. Yeah. And if you want to do the reverse, you just add the supports to it there, and you can use your cross view to
to fine tune and see all the layers of where it's going. So. Very, very cool there. There's a little bit of there's always hiding. There's always little things hiding in the crevices. So this is a really good way to see everything as you're scrolling through the Z height. So any other little tips and tidbits that you've learned while you're doing this?
Yeah, so you definitely want to keep the support material, not so far away, but pretty close to the edge of that. It'll do a good job of knowing how close to actually put it inside. One of the options that we'll show you later. It's the, I think we'll see it later.
Okay. So that's the first part. It looks like it's ready to go. Anything that you wanted to change here in the support
so we just want to make sure that generate support structures is on. And here it is, the horizontal offset from the part. I think I click on it a little bit later. Yeah, and this is the default. It's just 0.3 millimeters. I've seen people increase that just in case. What I've noticed too, it's that the type of nozzle that you're using. So on something like the Taz that has a very fat nozzle, the support material isn't going to come off as easy as it does on something that has like a skinnier nozzle. And the nozzle on the Type A, when we do the review on it, you're going to see it's just a little tube. Yeah. Like they've really figured out how to make an extruder. Yeah, okay. It's not like this giant bulky, you know, huge, you know, crap everywhere. It's just one
smallness
tube.
Is good here. So tell me, the horizontal offset, now that's the distance between the actual part and the support material?
Yeah, it's how it's touching, yeah.
Okay, so that is super fine control that you got there. You really don't have that control in other slicers. So what else have we got going on here? Is this
I think that's all that we needed for this, yeah. This is all we needed for that. The max overhang angle, I think, is being generated off what you selected in your custom support setup.
I saw real quick 10% infill for the actual support. So you have independent support support for your support material. So that's really, really nice, very helpful. And when you're ready to slice, you just prepare to print. Select your,
is another value that you get with this too. It's being able to check and run through all of the Gcode. So again, you can go through your cross section here and just look at what all of the tool path is going to be for this. So if we zoom in here, you can actually see where the make sure that the support structure that it's actually building underneath the rotating cylinder isn't going to be too much. So you can go ahead and check that, and you can see that it's just a tiny little bit of support that is added on there. It's like literally like 2 layers of support that is holding all of this up, and that comes off really easy, like we showed with a palette knife. Yeah, it's actually a knife palette, I think. Okay. And then you can see the top here where it's holding the rest of the gun together. It's small, like 2 layers worth of support material. And you can just check that to make sure that there aren't any errors in it.
What was the actual infill for the gun itself?
The gun, I think we used 8% infill, which is why it's pretty light to wield around. You don't really need much more than that.
What about your shell count?
The shell count was 2.
Okay, so it's pretty standard stuff.
Yeah, the only things I needed to actually edit here, I think, was the top layer height. I think I had it at 4 just because of the barrel right there. We want to make sure that that closes up all nice.
Okay.
And that is some of the techniques and some of the walkthroughs of setting up some custom support inside of Simplify 3D.
Yeah, definitely awesome indispensable tool that really helped achieve this one. Definitely recommend it. We can't recommend it enough. And of course, we'll be bringing you guys more tips and techniques that we use for slicing, because that's a very, very important part of 3D printing, if not the most important part. So we got another cool tip on sort of splitting it up inside of Maya, or your favorite CAD package.
Yeah,
do you want to
we're going to run through Maya on how to split things up inside Maya.
Or do you want to show us live? Do you want to show us some support removal?
Oh yeah, let's go ahead and get some support removal.
I'm going to go and do some camera things. We're going to go over here and we'll get the camera set up. Okay. So this is exciting. This is what it looks like when you print it out. It actually looks like it's done. Like the support is very, very beautiful. Like it's a shame that we have to throw this stuff away.
Yeah, it's very artistic the way that support material comes out. Yeah, so this is it. Let's go ahead and start removing this.
Okay, do you want any tools, or do you just do it by hand, right?
No, you can just do this by hand. It's simple. That's it. Boom. Boom.
Oh, so this is the part that almost didn't make it, huh? You can see that there.
I like talking about how easy it is to just easily flick off, and I just realized that I've never shown it. So there you go.
Whoa.
Just flick it all off.
Okay. Well,
now this was incredibly hard to do before. Like we could only do this with ABS, but because, you know, the way that it's generating these supports, we can do this in PLA.
We've seen people use Dremel, you know, power tool to it can be very not fun to remove support material. But of course, Simplify 3D makes it fun, so that's very cool.
Yeah, I really love the way that it does the infill of that. So it's pretty hollow when you look inside there.
Very hollow.
Nice little sandwich. And I'll need a spatula to get this out. But yeah, that's pretty much it. Very easy to remove. I really love the way that it's generated. Like we said, it's like an art piece itself.
Yeah. It is very good stuff.
There we go. That is what you're paying for. A very beautiful model.
Thanks. Very cool. Okay. Now that we got that, let's go ahead and take a look at some CAD techniques.
So this is some pretty simple slicing of how I cut up everything inside of Maya.
Okay, so this is what the file looks like when you open it up.
Yeah, so this is a quick tour. You get a complete blade with all the geometry. You just have to merge the handle over with the rest of the gun, depending on whether you want to switch it up or not. And I also run through the techniques of generating your grips inside of Maya.
I actually have one question that I don't think I've asked you. How is it needs to be a manifold design. Now, how is the revolver sort of be able to move but not merge to the actual thing? Is it?
We just don't merge it.
You just don't merge it.
We export
right?
it. Yeah, you just don't merge it. Yeah.
Okay, so it's more like a combine. They're really separate parts. It's because they're printed at the same time.
That is a good tip, actually. Do not select the revolver and hit combine. You want to select the blade, the handle, and just combine that.
Okay.
And then when you export, select the revolver as well and export that uncombined.
Uncombined. Okay. So yeah, you want to.
Although because it's not touching it, it would probably still work anyway because it's just floating in the air. I think there's like maybe a millimeter of space, and you can kind of see it in the model there where it's sort of just floating. In the middle of the cylinder that's holding it in place.
So tell me about the handle here. We're kind of looking at the
So here we're trying to figure out where we're actually going to cut this, because the way that you want to be able to orient this on your plate, you want to have a flat bottom. That's why I cut this here. That, and because this is like 304 millimeters. And again, you don't want to go all the way up to your max, just in case, it can't really print that high.
Yeah,
so you want to
10 below.
Yeah, so for a smaller printer, you might want to cut it like maybe right here. You definitely want to keep this hole like around this much of the model intact, so it has enough strength to hold the rest of the blade. So I would probably cut it up here if you can.
Okay.
And that should be enough on like a 150 mil printer like the Simple.
Right on.
So I include the skinny stick geometry so that you can use a Boolean command to sort of cut those holes into where you're going to slice. Cool. And inside Maya, to do that, we're going to use the slice plane tool. But before that, we're going to go ahead and use our measurement tool the distance tool to figure out how much we have to actually cut. And we'll just adjust that and figure out if I had a 150 millimeter printer, it'd be cutting right around there for the blade tip.
Okay.
And once you figure that out, you want to grab your geometry and move it up and move it to the middle of where the cut is going to be.
That thing on the side there that's like right here, that is such an essential tool. Like I really wish 123D had this. This is our tree. This is like our layers.
Oh, our hypergraph.
We have a hypergraph. We can
you can see down there all of our layers.
Oh my goodness.
Yeah, this would have been
incredibly difficult because
not
you can
fun
select
to do
things in groups and you can see at a glance without actually looking at your artwork. All the objects are in your scene. So this is a really crucial thing. I sort of wish we had that in 123D, but that's why you use the right tool for the right job.
Yeah, so here where I'm just showing off, where to actually slice that, how to move that across. I'm using the plane cut tool to add a cut there. And once we got that, we'll make a copy or a duplicate of the object and then hide that. So we can then select, do an inverse selection on that, and then cut the parts that we're not going to need. So if you scrub a little bit ahead, you can just see just doing an inverse selection here. So where we have just the tip left, we'll make sure it's still at 150. And then here is the geometry we're going to use to do the booleans. Okay. So here we'll just go into, and here's a quick little tip too. When you cut that out, you're going to have a missing face on the bottom, and we'll just go up to, what was it, mesh, and then fill a hole to sort of complete your model there. And then we'll just delete the history on that so that it's more easier to play with when you're doing booleans.
Yeah, you want to keep it the memory load. Okay.
Yeah, so it doesn't have so much so much stuff in cache. Okay. So just do a simple difference Boolean on that, and we can just hit the G key to continue to do that.
Very nice.
Which 123 had some of that too, like a way to like key commands that just do again, command. Right. And we'll do the opposite for the other side. We'll unhide our duplicate, hide our tip, and then select and delete the upper tip there that we've already created. Right. Go back into object mode, and then we're going to fill this again so we can close that hole that's in there. Okay. And then we'll just repeat the same steps over with the skinny stick geometry to create our holes for the actual physical sticks.
Okay, so you'll probably want to, depending on how many pieces you slice it up, you're going to have to use that intermittently and where you want. So.
Yeah, so you definitely want to make duplicates of that geometry so we can reuse it again.
Yeah. Okay, and always make a backup, right?
Yeah, this is another reason why we love being able to use groups and things, because when you're first experimenting with things, the first model is probably not going to be the way that you want to go with. So you want to have backups before you did, a couple of commands.
That's right.
And that's some of the tips, or that's some of the techniques on slicing up your parts inside of Maya. You can definitely do this inside of 123D. You just use the, I think like a plane cut tool to sort of cut all of this up. And yeah, you can import it as an STL if you want to cut this up inside of 123D.
Okay, and you could probably import it into any other Autodesk packages. They seem to work really well now with each other. So.
Oh yeah, they're all interoperability, whatever they call it.
So, show us the Gunblade one more time, and there you go. And just a little background story. So Lamar, you showed off a claw shot during the show and tell that we have every Wednesday. You guys can actually check that out too. There's a show and tell every Wednesday at 7:30 p.m. Eastern time. And you showed off the claw shot, showing off the Type A machine and how big you can make things. And then Lamar's like, okay, I want a Gunblade. So we were like, what is Gunblade? And we looked it up. We found, it's a very popular iconic sword. We've seen it before, but we didn't know much about the history of it. But now we do. It's an infusion of a gun and a sword by Squall in Final Fantasy VIII. Very, very cool gun. And, quite a few cosplayers have made it before. There's like tutorials on how to make it. With sort of foam and wood and things. But this is the first time I think anyone has 3D printed it. So congrats to you. It's the first time anyone's 3D printed and modeled it.
And if you're not going to be swinging this too hard and you need to travel to Comic-Con or something,
wow, that's a good point.
You can
take it apart.
Yeah, you can. You don't have to glue it together. You can just have this with the skinny sticks on there and just break this up.
Or magnets.
Or magnets. Yeah, that'd be pretty cool if somebody does a mod for that. Definitely let us know in the comments below.
That would be cool.
We'll definitely link to that. And I think that's all we have for this week's show.
That's this week's show, folks. We really hope you guys enjoyed it. We got some things for you, of course. There's a coupon code.
That's right.
Thursday.
Get the filament that we used to create this, and we'll have the printers in soon for this.
That's right, the Type A machine. We've been using it for quite a few months now. It's one of our favorite printers, just because it's so damn massive and the quality is so nice. So we'll have a nice video review for you guys in the coming weeks. Yeah, it's coming in the shop. I think we're in contract phases right now. So
enter in the code BLADE, get your 10% off of all your 3D printing accessories, PLA, NinjaFlex, printers.
Oh yeah.
Expires tonight at 11:59 p.m.
So get on it. We also got some cool links for you guys. All of our projects, our DIY projects, they're on Adafruit Learning System. We also got some other cool things like wearables and a lot of other things like that. We always share things on our Google+. Where's the blog, Pedro?
plus.google.com/+Adafruit. Check it out there. Join the show and tell every week. And then every Thursday, we have blog posts galore for you guys. Just search tags 3D Thursday, and you'll find all those.
That's right.
And then, of course, follow us on Twitter, Instagram, Thingiverse, where you see some of the behind the scenes.
Yeah, we got a lot of cool photos that you uploaded for the Ember. So if you want to see more stuff on the Ember and maybe some more fail art and things like that on my Instagram, I'm there too. But until next week, folks, remember to make, share, and repeat. I'm Noah. I'll see you guys next week.
See you guys. I'm Pedro. See you guys next week.
Yeah. Bye, everybody. Thanks for watching.
See you.